Bismillahirrahmanirrahim. So let us consider this problem. Monitor 3 consecutive packets going through an internet router. Based on the packet header, each packet can be classified as either video, designated by V, if it was sent from a YouTube server, or as ordinary data, designated by this D. Your observation is a sequence of 3 letters. So each letter is either V or D, because the packet can be either video or data. So for example, 2 video packets followed by 1 data packet corresponds to VVD, video, and then data, right? So write the elements of the following sets. A1, second packet is video. B1, second packet is data. A2, all packets are the same. B2, video and data packets alternate. A3, one or more video packets. B3, two or more data packets. So for each pair of events, so these are events, right? A1, A2, A3, B1, B2, B3 are examples of events of the experiment we are considering, right? So for each pair of events, A1 and B1, A2 and B2, and so on, identify whether the pair of events is either mutually exclusive or collectively exhaustive or both. So let us first of all find the sample space of our experiment. This will help us identify these events, which are the subsets of the sample space. So let's begin the solution. So there are 3 elements of each outcome, and each letter can be either V or D. We can actually denote them with either 0 or 1. So if you know combinations of 0 or 1 for 3 places, we can write the sample space. For example, if we have 3 bits, we can write it like this: 0 0 0 0 1 0 1 0. This is one binary, this is 1 decimal 1, this is decimal 2, then decimal 3, 0 1 1 1 0 0, right, 4, and then 1 0 1 5, this is 1 1 0 6, and then 1 1. So these are 1 2 3 4 5 6 7 8 possible outcomes, right? So similarly, for our case, we can designate, we can for example take our data as 0 and V as 1, and we can just replace the zeros with D and V with 1, and we can write down our sample space, right? So this will be D, D, and D here, then D, D, V, then D, V, D, then D, V, V, then V, D, D, then V, D, V, then V, V, D, and then V, V, V. All three packets are video in this case. So this is the sample space of the experiment that we are considering. Now let's write down the events. The event A, right? And event A is the second packet is a video, right? Second packet is a video. So from this sample space we can see this is here the second packet is data. This is not the element of this event. So this DVD, for example, the second packet is a video. Here again the second packet is a video, DVV, right? Then this one, VVD, and then VVV. So this is event A, so which is a subset of this sample space. Similarly, the event B1. So, and the event B1 is second packet is data, right? The second packet is data. So this D, 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 then DDV, and then VDD, and then VDV. The second packet is data here. So this is event B1. Similarly, we can write down event A2, and event A2 is all packets are the same. All packets are either video or all packets are all data. So we have only two packets which conform to this definition. It is D, all packets are data, and V, all packets are video. And B2, the set B2, the event B2 is video and data packets alternate. So if there is a video, then data, and if there is data, then there is video. So these packets alternate. So in this case, there is no alternation, there is no alteration, there is an alternation here. So we have data, then video, and then data, right? DVD, right? And we have this also VDV. And there are no other packets where this alternation occurs. Similarly, A3, the event A3 is one or more video packets, right? One or more video packets. So except this packet where all the packets are data, all other packets have at least one video packet, right? One or more video packets. So this is DDV from here, then DVD, then DVV, VDD, VDV, VVD, and VVV. So these are the 7 elements: DDV, DVD, DVV, VDD, VDV, VVD, and VVV. So this is event A3. Event B3 is 2 or more data packets. So 2 or more data packets. So surely this DDD, there are 3 data packets. There are 2 data packets here. So DDV, 2 data packets here again. DVD, only 1 data packet, right? And VDD here, there are 2 data packets, and this is one data packet and no data packet. So only these members, right? So now let us check whether all these combinations of A1, B1, A2, B2, and A3, B3 are mutually exclusive and collectively exhaustive or no, right? So 2 sets are mutually exclusive, A1 and B1 are mutually exclusive. For example, let me write A and B are mutually exclusive if their intersection is null set, right? And 2 sets A and B are collectively exhaustive if their union is the universal set or the sample space, right? Here in this case. So mutually exclusive and collectively exhaustive. So let's test A1 and B1. A1 intersection B1. So if we intersect, let's find if there are any similar element. If any element is similar in both these sets, so we find out the elements are unique for each set. There are no elements which are common to both the sets, and we can say that their intersection is phi. So A1 and B1 are mutually exclusive, right? And A1 union B1, let's see if we combine the elements of both the sets. So let's see. So this is DDD, DDV, right? And then we get a DVD from here, right? DVV from here, VDD from here, right? And VDV from here, VVD VVD from here and VVD from here. So yes, their union is the sample space, so they are collectively exhaustive. Right? Uh, Similarly, A2 and B2, A2 intersection B2, uh, uh, none of the elements of A2 and B2 are common to each other, so their intersection is phi, so they are mutually exclusive. So DD is not here, VV is not here, and similarly these elements are not here, so mutually exclusive. A2 and B2 are mutually exclusive, but does their union produce the sample space? So the answer is no. If we combine the elements of both these sets and we find the union, then this does not give us sample space. So uh, not collectively exhaustive. So not collectively exhaustive. Similarly, A3 intersection B3. So if we intersect A3 and B3, so it is not a disjoint set, right? It's not the phi set, the null set, because you see, so this DDV is here, right? This DVD is also here. So the intersection is not a null set. It's not a null set. So not mutually exclusive, right? But does their union produce the sample space? So you see, this set is excludes only this element here, right? So A3 is a subset of S, and it only the element missing is this element from this set. So if we take the union of A3 and B3, so the element DDD is here, and if we take the union, this will give us the sample space S. So yes, A3 union B3 gives us sample space, so they are collectively exhaustive. So right, so this finishes and completes this solution to this problem.